kcse revision channel. Marinda Chemistry Girls Special School, a teacher of mathematics and chemistry. Kindly subscribe, click the notification bell, you get notified once I upload a new video. Today we are looking at Form 2 work, carbon and some of its compounds. I have done some summary of carbon and some of its compounds. So in carbon and some of its compounds, so we must first of all understand the allotropes of carbon. We have the two major allotropes of carbon, that is diamond and graphite. We have other forms of carbon like charcoal. We have the lamp plug, and so many others. So in this case, let us look at the main allotropes of carbon. What are these main allotropes of carbon? One main allotropes of carbon, it is diamond and graphite. So you can have carbon in diamond form, or you can have carbon in graphite form. And this diamond, it has a density of 3.5 grams per cubic centimeter, and this high density it is due to the continuous close packing of the carbon atoms. This diamond, it has also has a high melting point. A melting point of 3,700, and the reason why it has this very high melting point, it is because of the strong covalent bonds between the structure. So, and this diamond is it is used to make drilling machines due to its hardness. As you know, that diamond is one of the hardest known substances. So, because of its hardness, whereby the atoms are closely packed, so it has what we call it the rigid mass, and that is why it is used as to make drilling machines due to its hardness. You can also have another allotropes of carbon, which is graphite. It has a low density of 3.2 grams per cubic centimeter as compared to that of diamond. And in this case here, it is due to the spaces between the layers. Remember, in a diamond, we have the close packing of the carbon atoms, and that is why it has a very high melting point. In this graphite, there is a spaces. We have spaces between the layers, and that is why we have now it has a low density of 2.3 grams per cubic centimeter. Therefore, this graphite it also has a high melting point and a boiling point compared to that of diamond. In fact, graphite has a melting point of 4,800 degrees, and the reason why it has this very high melting point and boiling point is because of the strong covalent bonds between the structure. Now, what are now the uses of this graphite? One use of graphite, it is used to make pencil leads. It is used to make this pencil leads. And this case here, and the reason, the property that makes it to be used to make as a pencil leads is because carbon can slide over each atom. That is the property that makes this carbon, this graphite to be used in making pencils. Now, under the chemical property, I have done just one summary here, whereby we have stove Chico. This is stove Chico. We have at the bottom here. So let's say that we call this one here region A. We can call this one here region A. We call this one as region B. And then we can call this one as part C. So in this part here at the bottom here, there is a sufficient supply of oxygen. So what happens here, when there is a sufficient supply of oxygen, carbon burns completely to form the carbon dioxide. So when there is a sufficient supply of oxygen, carbon burns complete. There is a complete combustion at this part here, and then there is a formation of the carbon dioxide. So in this region here, the carbon which has formed from the top here, from the first part in this region A here, it is reduced by this coke, the carbon, the charcoal. It is reduced by, so you have this carbon dioxide can react by the carbon, and then it is reduced to carbon monoxide. So in this region here we have the carbon dioxide gas. Then we have at the top here where we have the burning with the blue flame. There is now here we can have the carbon dioxide which has been produced here. So it is reacted again with oxygen, it burns with oxygen, and therefore the carbon dioxide gas is produced. So sometimes you will be required to explain what is happening in each part or writing the question of the reaction that is taking place in each region here. This is top gas. One of the poisonous gases being produced here is the carbon dioxide or the carbon monoxide. Why? This gas is a silent killer. And if the stove, this stove chico is used in a poorly ventilated room, there is a production of this carbon monoxide, whereby when we have this carbon monoxide in the blood, it combines with the blood and it forms a substance called carboxyl hemoglobin. The carboxyl hemoglobin, it causes what we call suffocation. So these gases are very poisonous gas. It should not be used in a room which is poorly ventilated. In fact, this one is a silent killer gas. So how does this carbon now react with the acids? The reaction of this carbon with acids now. In the first case, we have carbon reacting with the concentrated sulfuric acid. Carbon can react with the concentrated sulfuric acid to form carbon dioxide gas, the sulfur oxide gas, and then we have water. So what are the observations you can see in this case here? There is this carbon, the color of carbon here is black. So this one here, this one, it is black. So what happens when it reacts with the concentrated sulfuric acid? A black solid dissolves. That is the first observation. So you can see the black solid dissolves, and then there is a production of a gas which has a pungent smell. And that gas is the sulfur oxide gas. Of course, alongside that one, we have the formation of the carbon dioxide gas. That is the reaction when carbon is reacting with the concentrated sulfuric acid. The carbon which is black, the black solid dissolves, and then there is a production of a gas which has a pungent smell, and that gas is a sulfur oxide gas. How does it react with nitric acid? So with nitric acid now in this case here, there is a formation of a brown gas. And the only brown gas we have is nitrogen oxide gas. So what happens here, the first observation you can see during when carbon reacting with the nitric acid, so you can have a brown fumes, and this brown fumes is of nitrogen oxide gas. Of course, there is water, and of course, we have the carbon dioxide gas. So another observation you can have that this carbon here is black, so the black solid dissolves and then we have a formation of nitrogen oxide gas. So when asked you to state and explain the observation made when carbon react with the sulfuric acid, it can react with nitric acid. This is normally the observation that you will be able to make. Now, we can also have the compounds of carbon. We have two major compounds of carbon, that is the carbon dioxide and the carbon monoxide. So here we have the preparation of the carbon dioxide. In the first case, we have the reagent of calcium carbonate, and then we have a dilute nitric acid here. Then also, once the gas has been produced, it is passed through water, or it is passed through sodium hydrogen carbonate. And also, we can also have the anhydrous calcium chloride, or you can have the concentrated sulfuric acid. So what you need to understand during the reaction here, that calcium carbonate will react with the diluted hydrochloric acid here. We can have the calcium chloride, we have the carbon dioxide gas, and of course you can have water. The major observation you can make here is effervescence. There is a production of effervescence. Effervescence is seen. Purples of the gas are seen. The effervescence is seen on the purples of the gas, and that gas is the carbon dioxide gas. Now, in this, after we have the carbon dioxide gas, the gas is passed through either water or sodium hydrogen carbonate. What is the purpose of this water or sodium hydrogen carbonate? The purpose of water or sodium hydrogen carbonate is to remove the traces of hydrogen chloride. It is just to remove the hydrochloric acid. So the purpose of this water or sodium hydrogen carbonate in this experiment is just to remove the traces of hydrochloric acid. Then once the traces of hydrochloric acid has been removed, the gas is passed through concentrated sulfuric acid, or we can have anhydrous calcium chloride. And what is the purpose of either anhydrous calcium chloride or the concentrated sulfuric acid? The purpose of the concentrated sulfuric acid or the calcium chloride here is to dry the gas. So the two can be used to dry the gas. You either use anhydrous calcium chloride or the gas can be dried using the concentrated sulfuric acid. Methods of the gas collection. The gas is collected by the downward delivery, as you can see on this diagram. So the methods of the gas is by downward delivery, or we call the upward displacement of air. Why is the gas collected by the downward delivery or the upward displacement of air? It is because the gas is denser than air. Once the gas has been dried, the carbon dioxide gas, dry carbon dioxide gas is denser than air, and that is why it's collected by the downward delivery or the upward displacement of air. So, under the physical properties, the gas is slightly soluble in water. It is denser than air. It is denser than air, and that is why it is collected by the downward delivery, as you can see on that diagram. And also, you will be required to give uses of the carbon dioxide gas. It can be used in making the manufacture of baking powder. It can also be used in the manufacture of sodium hydrogen carbonate in the solidifying process. Then we have another compounds of carbon is carbon dioxide. How is the carbon dioxide being prepared? What are the reactions? So, with me, you can see here, we have the concentrated sulfuric acid. You can have the methanoic acid, or you can have sodium methanoate in the presence of heat. Then the gas is collected over water because it is insoluble in water. So you have we can have the sodium methanoate. So you have a reaction between the sodium methanoate and the concentrated sulfuric acid. Sodium methanoate here or methanoic acid. Then we have the concentrated sulfuric acid. Then we can have the sodium hydrogen carbonate plus carbon dioxide gas, then plus water. Simply that is how the gas is prepared. The gas is insoluble in water, and that is why it is collected over water. And then the gas is tasteless, it is colorless and odorless under the physical features. Under the physical properties. Now, there are some important things you need to know about the carbon dioxide gas. One use of the carbon dioxide gas, it is used in the manufacture of baking powder, or it can also be used as fire extinguishers. So before I come to the fire extinguisher, we have this carbon dioxide which is used in the manufacture of baking powder. So what is the roles of this CO2 in soft drinks? The CO2 normally when you are opening a bottle of soda, you can see the effervescence or the purpose of the gas coming out. And that is normally concentrated, and that's normally the carbon dioxide gas. Now, what is the purpose or the role of the carbon dioxide in that soft drinks? It is act as a preservative, or it can also be, it gives a taste, or it adds flavor to that soft drinks. So one of the examples of a soft drink is normally a soda, whereby it can give a taste, or it can add flavor to that soft drink. Now, when opening, when a bottle containing soft drinks is opened, there is an effervescence as carbon dioxide is dissolved under pressure is released. Sometime now in this case, that is when we are required to state and explain the observation made when a bottle containing the soft drink, a bottle containing soda is opened. Normally there is effervescence because there is this carbon dioxide which is dissolved under pressure. When it is released, you can see that effervescence. We have also the tartaric acid in this baking powder. We have said that one use of the carbon dioxide is used in baking powder. Now, what is the role of the tartaric acid in baking powder? Tartaric acid reacts with the sodium hydrogen carbonate. So what we have is in that baking powder, it is sodium hydrogen carbonate. So the tartaric acid now, it reacts with a sodium hydrogen carbonate to produce the carbon dioxide gas. And that is why now, in most cases, when you're cooking the mandas in your homes, I know that most people, the Christians normally do this. The Christian, they celebrate the birth of Jesus normally during December. That's when most families normally cooking mandasi. So what you can see during the cooking of mandasi, there is a racing, a dove will just race. What we are saying that when you put the mandasi on a frying pan, it will just increase in size. We are saying now that the dove is just racing. That is the dove which is racing. So when you're cooking mandasi, what is happening? When you put the baking powder in that the baking powder contains sodium hydrogen carbonate. So when you put that mandasi on the frying pan, it will just raise, it will increase in the size. What is happening there? The sodium hydrogen carbonate will just decompose to produce the CO2. So as the CO2 finds its way out, that is why we can have that the mandasi will increase in size, or we can say the dough rises. So when you're cooking mandasi using a baking powder, the dough rises. Baking powder contains sodium hydrogen carbonate, which decomposes on heating to produce carbon dioxide, which makes the dough to rise as it forces its way out. And that is why in most cases the mandasi always have cracks. So when you go, when you visit an hotel and you have ordered a cup of tea and the mandasi, kindly try to look at it. If it can have some cracks. So if mandasi has cracks, it means that there was the decomposition of sodium hydrogen carbonate, which produces CO2. So as the CO2 finds its way out, it will just form the cracks. Now, another use of this carbon dioxide, it is used as a fire extinguisher. So, what are some of the properties that makes this gas to be used as a fire extinguisher? Why is that the carbon dioxide can be used to extinguish fire? One reason why it is used, this gas does not support combustion, it is denser than air. So what is happening, if it does not support combustion, and then it is denser than air, so when it's used to put off fire, it will just form a blanket, it forms a blanket, and then cuts off the supply of hydrogen. So the supply of oxygen, sorry. Therefore, the properties that makes this carbon dioxide to be used as a fire extinguisher: one, it is denser than air, it does not burn, the gas is not, it is not poisonous, it does not support burning, and that's why this can be used as a fire extinguisher. So on my right hand side here, we have the types of fire extinguishers. Now, these types of the fire extinguishers, sometimes you will be required to name the types of fire extinguisher. So, one fire extinguisher here, we have the soda, we have this one as the soda acid extinguisher. What is this soda acid extinguisher? This one contains sodium hydrogen carbonate at the bottom, and then we have the sulfuric acid at the top. So when the two react, they produce the carbon dioxide, which will put off the fire. Then another one, we have the foam extinguisher. The foam extinguisher, normally this one, it contains sodium hydrogen carbonate also at the bottom, and the aluminum sulfate at the top. So when the two react, they can produce a CO2, the carbon dioxide, which can put off the fire. And then we have the carbon dioxide extinguisher. So these are the types of the fire extinguisher. This is a very small summary of the carbon and some of its compounds. In my next video, I will be uploading the manufacture of sodium carbonate, that is a soluble process. Kindly follow my channel, you click the notification bell, you get notified once I upload a new video. Thank you.